All right, so we're now at the second part or second video of this series. So again, life expectancy in Massachusetts counties is 79.9 years on average. Now, this will be interesting. So here's our 79.9. This was actually the computation um, that was done by a calculator. So you have 79.85714. We're going to travel over to the life expectancy set of data. You notice we only have 3 data points. I'm sorry, that's wrong. We're into 3 decimal values, so 0.325, 0.780. And when we do it, we're going to get a mean of 80. My apologies, that's the sound of our garage door. So let me show you how to get this in the world of Jamovi. So what we're going to do is we're going to click up here on data. I apologize, I lied. We're going to click up here on analysis. And then what we're going to do is we're going to click on exploration, and we're going to do descriptives. And for a moment, let's just go back to our variables. And we notice we don't have anything at this point in time presented. So we have missing, mean, median, but there isn't anything listed. So we need to identify the variable that we want to look at. So we're going to click on expectancy. We're going to hit this arrow over, and we're going to have variables. Now, looking at this list, we have the sample size. We have a number of missing values. We don't have any. We have the mean. We have the median. We have a standard deviation. We have a minimum, a maximum. Now, I'm going to do a little bit more digging around in this, but for right now, this is what we have listed. So the mean's 80.0, median's 80.1, standard deviation is 0.843. Our minimum is 78.4, and our maximum is 81.2. We can hit a thing called the standard error of the mean, which is the standard deviation, and it will be divided by the square root of the sample size. So that's how they end up getting the 0.225. So you'd go 0.843 divided by the square root of 14. Okay, so we'll click that off for now. We can click on IQR, interquartile range. And so to sort of emphasize that or support that, we'll click in our percentiles. And so you can see that our 25th percentile starts, let me say it this way, it's going to end at 79.3, and then the 26th to the 50th percentile starts just past 79.3 and then goes on to 80.1 and so forth. And so the distance from 80.4 to 79.3 is 1.06. So this is your interquartile range. This is your Q3. This is your Q1. And this is your median. The 80.1 is your median. Notice those match up. Okay. Let me go a little bit farther. I don't remember what cuts does. I don't know that changed anything, did it? No, it didn't change anything. All right, so I'm going to scroll down a little bit, and I'm going to make a couple of graphs. Now, remember I said we don't have the ability to make a dot plot, but we can make a histogram. And if you look at the histogram, it has the high point about where the dot plot does. It has approximately the same height as the dot plots that we looked at in these regions. Let me go back real quick and just sort of show you what I mean. So go to our slides. It's not a perfect match, but they're going 78, 79, 80, and 81, and the shape is basically up and then down, and the shape is basically up and then down. They don't have 78 listed here, but that's what this value is showing on the very left. Okay. We can add in density. It's just going to show you how it goes up, and then around 80, it peaks out, and then it heads on back down. All right. So I'm going to do a box plot as well. And here's our box and whisker plot. And the median is here. This is the distance from Q2 to Q3. This is the distance from Q1 to Q2. This is our minimum. This is our maximum. So it's the 5-number summary that presents itself. So we have our minimum, our Q1, our median or Q2, our Q3, and our maximum. And that's called our 5-number summary. So our box and whisker plot is tied right into our 5-number summary. Okay, let me go back over here. I will scroll forward. There we go. The median is the value that splits the data in half. So half of the amount of data is above, half of the amount of data is below. Our median is listed as 80.1. So this darker bar right here is lining up with 80.1. Okay, 50% of the data falls below the median, 50% above the median. We can also compute the median of the life expectancy data. We've done that. So what's going on is there's a slight difference between the data that's here and the data that's here because of the ability to go farther out into the data sets or to the numerical values. Sorry, so it's not just 80.325, yada, yada, yada. They're getting a slightly different value based on rounding and that kind of thing. All right, let me go back here, go farther. Let's see where the mean and the median fall on the dot plot. Again, we're not able to make the dot plot in Jamovi. So we have our median. Hopefully you can see this. I'll try and get a little closer. So the mean is the red dotted line, and the median is the blue line. And notice what happens is that a mean gets pulled out by an outlier. So if we have more stuff that's farther away this way, the mean will get dragged into that space. The median is insensitive to outliers. So if we have 3 data points here and we have 3 data points here, then the median will land right in the middle. And if one is way out there, it'll still land in the middle. Okay, so let me go a little farther. All right, we're about at 8 minutes again. All right, we're going to pause here and I'm going to upload this video.